jelaskan dengan oke sebentar izin share screen ya. Oke, udah kelihatan belum? Oh, udah
aman.
aman ya. Oke. Ini kalau misalnya gua tiba-tiba koneksi gua mati, jadi kasih mohon maaf ya. Jadi semoga aman-aman aja malam ini. Oke, jadi ini untuk malam ini kita ada 2 chapter. Gua akan ngebahas 2 chapter ya, karena materi yang dibahas di 2 chapter ini gua rasa penting dan cukup banyak. Dan gua anggap bab 1 sama bab 2 itu kalian udah setidaknya memahami lah. Tapi kalau kurang paham nanti ada Gdrive itu isinya video pembelajaran gua tentang bab 2 dan bab 3 ya. Oke, jadi kita mulai aja. So let's start. Okay, so the first question is on vectors, which is to find the dot product of the following vectors and to determine whether or not they are orthogonal to each other. By orthogonal, this means 90 degrees, yeah. These two vectors, do they form 90 degrees or not? Now, for dot product, let's say this is vector A, and this is B. The dot product of A and B would be A1 B1 plus A2 B2 plus A3 B3. And so we're going to apply this here. And so U dot V is -1 times 2 plus 2 times -1 plus 3 times 2. And if we were to do the summation, this would be equivalent to -2 minus 2, 6, 2, equivalent to 2. Okay. And so because U dot V is not equivalent to 0, that means this is not orthogonal. Okay. So next, we're going to find the angle between both vectors because it's not orthogonal. Okay, so the formula to find an angle would be cos theta is equivalent to U dot V divided by the norm of U times the norm of V. And let's say the norm of A here is the square root of A1 squared plus A2 squared plus A3 squared. So and if we were to calculate this is the result. 2 over n, let's calculate norm U. This will be 1 plus 4 plus 9, that's root 14. This norm V is root 4 plus 1 plus 4, that's root 9, which is 3. And so this is 3 times root 14. Okay. And so next, we're going to calculate the value of theta simply by using cos inverse 2 over 3 root 14. And I guess to save time, if you want to plug this into the calculator, go ahead. But then now I'm just going to leave it here just to save time. Okay, so if U is orthogonally projected towards V, find the resulting vector. Or rather, orthogonally projected against V. That's the proper language. The formula would be, let's say W is the orthogonal projection. The formula would be U dot V times the norm of V squared times V. Okay, let me. Yep. And so this is the result. 2 over Norm v squared, norm v is 3, so the norm v squared would be 9 times 2, negative 1, 2. And so the result, and this results in 2 over, okay, 4 over 9, negative 2 over 9, and 4 over 9. So this is our resulting vector. Okay. Give me. Okay. Okay, so now we're going to move on to the next question, which is on the partner of dot product, which is cross product. And let's say we cross A and B. This is we're going to result in the determinant of a 3 times 3 matrix, in which the first row is I, J, K, A1, A2, A3, and B1, B2, and B3. And all we need to do is just find the determinant of this matrix. However, we need to do by doing cofactor expansion on the first row. Okay. And now we find the cross product of the vector U times V. The result is I, J, K, negative 1, 2, 3, 2, negative 1, and 2, which is equivalent to I. And if you remember the matrix of coefficients, if we're doing cofactor expansion, this is the matrix: plus, minus, plus, and so on, minus, plus, and so on, plus, minus, minus, plus, and so on. And because we're expanding it on the first row, so I would be positive, J would be negative, K would be positive. Okay, so the resulting expansion would be I. And in order to find this matrix, we cover up the first row and the first column, which will result in 2, 3, negative 1, and 2, minus, this because this is negative, J times, if we cover the first row and second column, this one, will result in negative 1, 2, 3, and 2. And finally, plus K. Yeah. Okay. Negative 1, 2, 2, and negative 1. And so the resulting matrix would be 4, 2, 7I, negative 2, negative 6, that's negative 8, plus 8J, plus 1 minus 4. Sorry, this is plus, let me just erase that. That would lead to minus 3K. And so this is our cross product. Okay. And with the new vector W, let's say we introduce this new vector, determine whether or not U, V, and W are coplanar to each other. By coplanar, meaning they are in the same plane. Okay. So in order to determine this, we need to use this formula. U dot V cross W. And this is the matrix. Actually, you don't have to do it in this order. You can do it in any order you want. It's fine. So the result, so because the U dot here will be on the first row. So this is negative 1, 2, 3. The second one would be matrix V, vector V, is 2, negative 1, 2. And next would be followed by vector W, which is 1, 0, 2. All we have to do is just find the determinant of this matrix. And in order to make things easier for us, what we can do is do cofactor expansion on the third row. So this will result in, this is plus minus plus 1 times 2, 3, negative 1, 2 by covering up the first column. Plus 2 times negative 1, 2, 2, negative 1. And if you were to reference this previous one, we're going to arrive with 4 minus 3. That's 7. So this is 7. Wait. So this is 7 plus 2 times negative 3. And so the result is 1. Okay, so this means that, give me, this means they are, wait, I've the because the result is not 0, it means they are not coplanar, meaning they don't belong in the same plane. Okay, so moving on to the next question. Okay, so the first one will be to find the area of the triangle. And let's say these three are the points that are on the triangle. So by vertices, it means these points represent the side of the triangle. Let's say this is A, this is B, this is C. Okay, so before we calculate, the first step that we must do is to find two vectors that make up the sides of the triangle. And that can be anything. That can be vector AB and AC, or vector BABC, or CACB. It's completely up to you. So for vector AB, so this time we're going to use AB and AC. So the vector AB would be 3 minus 1, that's 2, 2 minus 0, that's 2, 1 minus 2, that's negative 1. And AC would be 4 minus, 2 minus 1, that's 1, 3 minus 0, that's 3, 4 minus 2 is 2. Okay, and in order to find the area, we need to do cross product of these two vectors. So that will be cross AB cross AC. However, bear in mind, I'm sorry, not the cross product, but the norm of the cross product. However, the norm of the cross product is actually the area of a parallelogram atau jajar genjang, which looks like this. To find the area of triangle is half the norm. Okay, so now we're going to find the length by first finding the cross product. So we do the usual procedure, AB times AC. That would be IJK 2, 2 minus 1. And so I 2 minus 1, 3, 2 plus, minus J. Wait, here, minus J 2, 1, negative 1, 2 plus K 2213. So wait, let me just give more space first. Just this. Into the next slide. And so this will be 4 plus 3, that's 7i. 4 plus 1, that's 5. So that's minus 5j. Yep. Plus 6 minus 2, that's 4 plus 4k. And so the norm would be AB times AC equals root 7 squared 49 plus 25 plus 16. That is 25 plus 16 is 51. This is 100, yeah? Root 100. So this is 10. Oh. And we got a beautiful number, thank God. And so the area of the triangle is half times 10, which is 5. So we're done with this part. Now we move on to the next question. Where that ABC are the size of a parallelopipe. And the parallelopipe, it looks something like this. How do I know? It looks something like this. This is Z. This is Y. This is X. This is the origin. This is what it will look like. Hopefully I can draw vectors. Okay. If it's not that good, I'm sorry. Forgive me. This is the best that I can do. It looks something like this. And so the vectors here, these are the size. Let's say this is U, V, and W. And to find the volume would be the triple product, or U dot V cross W. And you can do it as usual. You can do it in any order you want. It won't be a problem. Okay. Because what we're looking for is the magnitude or the number, not the sign. So yeah. So it shouldn't be a problem. Hence, we're going to do the same thing to A dot B cross C. And this will be, and if you were to look at the previous slide, A is 102, B is 321. Okay. A is 102, B is 321, and C is 234. As usual, to make it easy for us, we're going to do expansion on the first row, cofactor expansion on the first row. This will result in 2314 plus 2 times 3223. So this will result in 8 minus 3, that's 5, plus 9 minus 4, that's 5, which is 10. Sorry, 2 times 5, so this is 15. And so we have the volume. Next, this is the most important, another important part of this chapter, which is to find the equation of lines. And so in order to find the equation of a line, we can have two different scenarios. The first one, we have 2 points on the line, or we have 1 point on the line, and one vector. And not just any vector, a direction vector. Okay. And find the equation of the line in la 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 la. Okay. And so we're given 2 points that are on the line. So we have scenario 1. So we have to find the direction vector of the line. Let's say that direction vector is v. We can do AB or BA. It's completely up to you. However, we're going to do AB for this case. AB is -2, 1, 1, which is B, minus 1, 4, 7. Okay. So this is -2 minus 1, which is -3. 1 minus 4 is -3. 1 minus 7 is -6. So this is our direction vector. All we have to do now is to find the equations based on these 3 criteria. And the easiest one that we can find given this scenario is the parametric equation, which is like this. Let's say L is equivalent to one of the points here. Now in this case, we'll use B. You can use A if you want, it's up to you. Is -2, 1, 1 plus a parameter T and -3, -3, and -6. Okay. This is parametric. Okay. And the next thing that we can find would be the Cartesian equation. All we have to do is just express each components here as a function of t. And from this part, we know that from the top row, we can say that x is equivalent to -2 minus 3t. Y is 1 minus 3t. And z is equivalent to 1 minus 6t. Okay, so if we were to change this into t form, it will be x plus 2 over -3. This will be t equals y minus 1 over -3. And t here would be z minus 1 over -6. Now, all we have to do is just equate all these three. And what we're going to get is, x plus 2 over -3 equals to y minus 1 over -3 equals to z minus 1 over -6. And if you would like to simplify this, go ahead. If you want to simplify it, go ahead. So all I can do is cross, cross, cross. This will result in 2. This is x plus 2 equals y minus 1 equals to z minus 1 over 2. And do not in any way whatsoever change this one, the constants. Just leave it like this. And so we have the Cartesian equation. And finally, what we're going to do is to do the vector equation. And we're going to do it based on the parametric form. And so for the vector, all we have to do is just write, let's say, L is equivalent to the x component is the coefficient of I, which is -2 minus 3t I plus 1 minus 3t j plus 1 minus 6t k. And so this is the vector equation of the line. Okay, so moving on, we're going to have a plane equation. And in a plane, let's say the plane looks like this. And let's say this arrow here is the normal vector of the plane. Let's say this is plane V. And this plane has this normal vector has components A, B, and C. The equation of this plane would be AX plus BY plus CZ equals to D. And X, Y, and Z is a point on the plane. And in order to find the plane equation, obviously we will need this vector here if given, or and also this vector given and the point on the plane. So vector, not just normal any vector, but the normal vector plus point, or we can also have a line which is perpendicular to plane plus 1 point or 3 points. Oh, and before I forget to tell you, this will go back to, we're going to go back a bit to cross product. The cross product, let's say AB. Let's say this is AB and this is C. C, which is C is perpendicular to both A and B. C can be formed by A and B. And so this is what the meaning of cross product. To find the vector that is perpendicular to both A and B. Okay, so next. Because we're going to need that concept here in finding plane equations. In fact, in number 1 here, we're going to use that concept. And so we're going to find a plane equation that contains these 3 points. Okay, and what we're going to do first is to find the vectors that are formed by these 3 points. In this case, we're going to do AC. AB would be 2, 2, -1, and AC would be 3. Sorry, 2 minus 1. Sorry, this is 1, 3, 2. And so these are our vectors. And as I've mentioned previously, because we have these 2 points that lie, these 2 vectors that line plane, we can find cross product. And this cross product is all the normal vector that is normal to this plane. And so this would be, let's say n equals to I, j, k, 2, 2, -1, 3, 2. This is equivalent to I 2, -1, 3, 2 minus j 2, 1, -1, 2 plus k, which is 2, 2, 1, 3. And so this is 7i, this is 4 plus 4 j plus 4k. And so this is our normal vector. Okay, so let me just create more space for a while. Okay, so moving, this will be the equation of the normal vector of the plane. So now we can write ax plus by plus cz plus d equals to 0. Well, it's up to you if you want to write it like this, but in this case, let's write it like this, because I'm used to writing it like this. And all we have to do is just now write 7x minus 5y plus 4z plus d equals to 0. And in order to find the value of d, we can input any one of these three three points, with the condition that that any of these 3 points lie on the plane. Okay, so 7 minus 5, 0, plus 4 times 2 plus d equals to 0, and this will result in 7 plus 8, 15 plus d. D is negative 15. Hence, your plane equation is 7x minus 5y plus 4z minus 15 equals to 0, or 7x minus 5y plus 4z equals to 15. Okay. Moving on to the next part, which is to find a plane equation that contains these lines and is perpendicular to this plane. Now, the key here, perpendicular to this plane, can you see that automatically we have the normal vector? We have the normal vector, which is 5x plus y minus 2z, because let's say the plane 1 is plane 2. This from top view, assuming this is from top view. This is plane 1, this is plane 2. And this normal plane 1, and this is the normal of plane 2. And if we were to extend this normal, to wait, I think that's happened. In order to find, that means we need to do an additional process, which is sociable. Okay, so let me change the question a bit. Let me change this to parallel to make it simpler, because if they are perpendicular, that means I have to find another vector which is perpendicular to this, and it will take a long time. So let me change the question, because if it's parallel, the vector, this will be the plane 1, plane 2. This will be the normal. And so all I have to do is just write n is equivalent to 5, 1, minus 2. Yeah. And so we have, it contains this line, x equals 2 minus t, y equals 4 plus 3t, z. And so all we have to do now is find a point that we can use. And the simplest one is to put t equals to 0, x would be equivalent to 2, y will be equivalent to 4, and z is equivalent to 0. Okay. And so now your plane equation would be 5x plus y minus 2z equals to d. All we have to do is just plug in the values. This is 10 plus 4 equals d, and d is 6. Hence your plane equation is x plus y minus 2 is 6. Next would be to solve this equation, and we have this is the last question for plane equations. Next we'll be moving on to the next chapter, which is about vector spaces. And in order to find an equation of a plane that contains the intersection of this plane and this plane, and it passes through this point. So what we're going to do now is to find the line, the intersection between this point, which forms a line. In order to do that, we need to convert these two planes into the augmented matrix, which is like this. 2 minus 3 minus 4, 5, 4, 1, 1, 1. Okay. And next, we need to convert this into reduced row echelon form. And we can do this by, I can knock out this 4 by minusing it with by subtracting it with the 2 times the first row. Okay, so R2 minus 2 R1, this will result in 2, 0, 1, 2. And so R1 doesn't change, so 2, negative 3, negative 4, and 5. So 1 plus 6 is 7. 1 plus 8 is 9. 1 minus 10 is negative 9. Okay. Now we can divide the first row by 2. This will result in 1 minus 1.5 and minus 2, 2.5. This is 0, 7, 9, and negative 9. Okay, so next we're going to knock out this negative 1.5. But first, if you want, you can divide this by 7, which is R1 over 7. I can just do this here just to save space. Which is this is 1, 9 over 7, negative 9 over 7. Okay, so now we just need to R1 plus 1 over 5, sorry, 1.5 R2. So the result will be 1, 0, 1, 0. R1 plus 1 over 5 R2. That would be negative 2 plus 3 over 2 times 9 over 7. That would be negative 2 plus 27 over 14. So this would be negative 28 over 14. So this is negative 1 over 14. So this is negative 1 over 14. This is 9 over 7. And now R2 doesn't change, so this is negative 9 over 7. R5, sorry, this 2.5 will be 2.5 plus negative 9 over 7 times 3 over 2. This results in 2.5 plus negative 27 over 14. This is 5 over 2 or which is equivalent to 35 over 14 minus 17 over 14. 35 minus 17 is, I think, 18 over 14. This results in 9 over 7. So 9 over 7. Now we have the row echelon form. Sorry, the reduced row echelon form. And as you can see, Z does not have a leading one. So if that happens, what we do is make Z to be equal to T, which is a parameter. And what we're going to get is X equals to 9 over 7. This one, move it to the other side, becomes plus 1 over 14T. And Y is equivalent to um Y is equivalent to, sorry, negative 9 over 7 minus 9 over 7T. Okay, and so this is the line that we're looking for. Next, we're going to find another equation of the plane that contains this line and this point. The first thing that we can do in order to determine that point will be to find two more additional points from this line. So let's say T is equivalent to 0. That means the points that we're going to get are 9 over 7, comma, negative 9 over 7, and 0. If T equals to 1, the points that we're going to get are 9 over 7 plus 1 over 14, that's 19 over 14, comma, wait, comma, negative 18 over 7, comma, 1. And so what we're going to do is find the cross product. And so let's say this is point C, this is point A, and point B. And so AB is 19 over 14 minus 9 over 7. This is 1 over 14, comma, negative 18 plus 9 is negative 9 over 7, comma, 1. Okay, next we're going to find AC, which is 1 minus 9 over 7 is negative 2 over 7, comma, 0 minus 9 over 7, which is 9 over 7, comma, 1. 1 minus 0 is 1. So next we're going to do the cross product of AB and AC. This will result in okay, this 2 will be 1, 1. This is 1 over 14 minus 2 over 7. Okay. And this is 9 over 7 minus 9 over 7. Is it right? Oh, it's the opposite. And this is equal to 9 over 7, 1, 1, 9 over 7. I minus 1 over 14 minus 2 over 7, 1, 1, J plus 1 over 14 minus 9 over 7, 9 over 7 minus 2 over 7, k. So this results in negative 9 over 7. Negative 18 over 7i 1 over 14 minus 2 over plus 2 over 7, 5 over 14 j plus 1 over 14 times 9. That's 9 over 14 times 7, that's 98 plus sorry, it's minus minus this one, which is 18 over 49. And so this is negative, okay, 18 over 7i plus 5 over 14j. So this is to negative minus negative 36 plus 9, negative plus 9 is negative 27j. Okay, so now we have this model here. Now all we have to do is to write this as the plane equation. And this is what we're going to get, which is equivalent to D. And in order to make it easier, we're going to put point C into this equation, and this is what we're going to get. Negative 18 over 7 minus 27 over 98. And this is D. And so all we have to do is just multiply negative 18 over 7 with 14 over 14. And we're going to get something over 98. And so 18 times 14, that is 23, 4, 7, 14, that's 2, 3, 4, 7, 74 dot 1 for 14, that's 4, 3, 2, 3, 4. 2, 3, 4. So D is negative 2, 3, 4 minus 27 over 98. And you're going to get minus 261 over 98. So this is your value of D. Okay, so now we're done with plane equation. So you can just put the value of D here. And now we're going to move on to the next chapter, which is chapter 4, which is on subspaces. So we have 11 questions in total, so we're almost done. Okay, first we have to, for subspaces, we have to prove that whether this P here is a subspace of M2 times 2 or not. And for something to be a subspace, this vector must be in the space let's say operation U plus V must be in the subspace. Operation KU must be in subspace. So these are the three criteria or axioms that would need to be met. And so first we need to prove whether this is a subspace of M2 times 2 or not. By this I mean AD minus CB equals to 1, whether it's valid or not. For 0, is it in the subspace? For A, B, C, D equals to 0, does it apply here? Well, no, because 0 minus 0 is not equal to 1. And so this also, if you find one criteria, just one criteria that is not met, then automatically this is not a subspace. So because 0 is not in this space, that means P is not a subspace of M22. Okay. Moving on, we have this equation here, which is A equals 2B plus C. Now, number one, let's just put 1 here. Number 1 is O in the space. So O meaning O. So all we have to do is just plug it into the equation. 0 equals to 0. And so this one is met. Now let's do the second equation, the second criteria, which is operation U plus V. So for that one, let's let A equals to A1, A2, and A3, and B equals to B1, B2, and B3. And A plus 1 and A plus B, is equals to A1 plus B1, comma A2 plus B2, comma A3 plus B3. Okay, so first we'll put A into the equation, into this equation. Hence it will be A1 equals to 2A2 plus A3. And B1 equals to 2B1 plus 2B2 and plus B3. And if we were to input this, it will be A1 plus B1 equals to 2A1 plus 2A2 plus 2B2. Or let me just fix this. 2 times A2 plus B2 plus A3 plus B3. And we have to prove that A plus B is equivalent to A plus B, right? Because there are also instances where this is not so for this case. Okay. And if let's add this two together, this will be A1 plus B1 equals to, I'll just shorten this, to A2 plus B2 plus A3 plus B3. And so second criteria, because this is the same as this, hence your second criteria is met. For third criteria is the product of K. So let's try KA is equivalent to KA1 plus KA2, KA2, KA3. And let's put it into the product. Will it be equivalent to this? So we have KA1 equals to 2KA2 plus KA3. Now you can see there are K on both sides, so we can factor out the K. Hence A1 equals to A2, 2A2 plus A3. Now this operation is the same as this operation, hence it's met. And because all three criteria are met, we can say that Q is a subspace of R3. However, what if I change this equation and make it 2B plus 1. Will it be met? A equals to 2b plus 1. Will it be met? 1 plus c. Okay, before I forget. Will this be met? No, it will not be met because of this. If I add plus 1 and plus 1, it will not be equivalent to 0. Okay, so therefore, and also in the first criteria, it will also not be met because if we were to plug in 0 into this equation, we know that 0 is not equal to 1, hence it will not be met. And so for this question where A equals to 2b plus c, Q is met. But if Q is equivalent to Q has the operations A equals to 2b plus c plus 1, it will not be met. Okay. Now moving on, we're going to discuss a linear combination. And so for a linear combination, it means that I can express any one. Let's say we have a vector v1, v2, and v3. If these three are linear, I can express v3 as a combination of, let's say, a v1 and b v2. This is called linear combination. Okay, so now we're going to prove whether or not the matrices below are linear combinations of each other in M2. And in order to do that, we have to write this equation. K1 times 1102 plus K2 times 1221 plus K3 times 0211. This equals to K1 plus K2 plus this one is 2K2 plus K3. This is K1 plus 2K2 plus 2K3. This is 2K1 plus K2 plus K3. So now we have 4 different equations here. So in order to create more space, I will have to move the second question. And in order to solve this, what we need to do is to find whether or not they are equivalent to 0. So K1 plus K2 equals 0. 2K2 plus K3 equals to 0. K1 plus 2K2 plus 2K3 is equivalent to 0. 2K1 plus K2 plus K3 is equivalent to 0. So now let's convert this into the matrix, which is 1, 1, 0, 0, 2, 1, 1, 2, 2, and 2, 1, 1, 0, 0, 0, 0. Okay, so now what we're going to do is knock out these two by R3 minus R1 and R4 minus 2R2. So this is what we're going to get, 1, 0, 0, 0. E minus, this is 2R1, sorry. 1, 0, 0, 0, 0, 0. This is 1, 2. This is -1, 0. Okay. And the second row is just 2, 1. And so we have officially we have our second row. So all we have to do, let me just add a new slide. So this will be 1 minus 1 is 2. So all we have to do here is just move row 2 to row 4 to row 2. And R4 times -1 just to make it quick. And 0, and oh guys, you're allowed to do multiple operations like this just for information, so that you can save time. 0, 2, 1, 0, 0, 0, 0. Now all you have to do is just knock out these three. And so we have R1 plus R2, R3 minus R2, and R4 minus 2R2. So we're going to get 1, 0, 0, 0, get 0, 1, 0, 0. And so R2 is 0. Therefore, R1 plus R2, this one is 0. R3 minus R2 is 2. 2 is 2. And R4 minus 2R2. So R3 minus R2, yeah, 2. This is still 1. Now we can just knock this last one out and then divide the third row by R2 by 2. Sorry. So we have R3 over 2, and we have R4 minus half R1. We get this. However, now we can conclude that K1 equals K2 equals K3, which is 0. However, this shows that the three matrices, let's just write this down here. 3 matrices previously are linearly independent. And so they are not linear combinations of each other. Or rather, they cannot be expressed as linear combinations of each other. And so we can conclude that this question cannot be solved. But rather, we've proven that they are linearly independent. And the strategy to express whether or not K1, K2, and K3 are linearly dependent on each other or can be expressed is to do trial and error. Or if it will yield a value here. Okay. Or else it will yield a value here. If there's a value here, that means it will be linearly dependent. Okay, next is whether or not these three vectors span R3. Now for spanning, Wait, give me a moment. We have to first express these three vectors as a matrix. And first of all, we have to write this as a linear equation. Sorry. Let's say x1, x2, x3 equals to c1, 2, 1, 2, plus c2, 1, 2, 3, plus c3, negative 2, 0, 1. And we have to express this as a coefficient matrix. And this is the coefficient matrix, which is 2, 1, negative 2, this is 2, 1, 2, 0, and 2, 3, 1. Now we have to find the determinant of this matrix. So let's say this is matrix A, so that A is, now we're going to do, I'm going to show you that a mixture of methods, which is finding the, using row reduction and cofactor expansion. And so this, what we have to do is R1 plus 2R3 in order to knock this out. So this is 0, this is 1, this is 2, 3, 1, sorry, 2 plus 4, this is 6, 1 plus 6, this is 7. Okay. And now we're going to do the cofactor expansion on this column. And remember, this is plus minus plus. And so the sign of this will be plus. And so this is equivalent to 6, 7, 2, 2, which is equivalent to 12 minus 14, which is negative 2. So that A is negative 2. If that A is not equivalent to 0, therefore vectors, or let's say this is a vector set S spans R3. Okay, next is about the coordinate and basis. So suppose we need to show that these three matrices can be a basis for M22, and then we have to find the coordinate vector of A relative to S. And by proving that it's a basis, we need to prove that these four are linearly independent. And spans M22. Okay. And in order to do that, we do the same step as previously, which is K1, 1, 1, 1, 1, plus K2, 0, 1, 1, 1, plus K3, 0, 1, 0, 1, plus K4, 0, 0, 0, 1, is equivalent to 0, 0, 0, 0. So we get the equations are K1 is equivalent to 0, K2 from this value, then K1 plus K2 equals to 0, K1 plus K2 plus K3 from this part is equivalent to 0, and K1 plus K2 from this one now, plus K3 plus K4 is equivalent to 0. However, we've proven that K1 is equivalent to 0. Therefore, if we plug it here, we have proven that K1 is 0. Therefore, K2 by second equation is equivalent to 0. By third equation, K3 is equivalent to 0. And K4 is equivalent to 0. So we've proven that this is linearly independent. And then, in order to prove that it spans M2, M22, we have to find the determinant. And this is the determinant, which is 1, 1, 1, 0, 0, 0, 0, 0, 1, 1, 1, 0, and 1, 1, 1, 1. As you can see, this is a diagonal matrix, with this being the diagonal. Or you can, if you want to rather do cofactor expansion on the first row, go ahead. So this will be 1, 1, 1, 0, 1, 1, 0, 0, 1. And so, because this is a diagonal matrix, this is equivalent to 1. Wait. Because the determinant is not equivalent to 0, therefore it spans M22. So therefore we've proven that this set S is a basis for M22. Okay. Okay, so now to the heart of the matter, to find the vector coordinate of A relative to S. And so we've known that A is equivalent to 1, 1, 0, 0. And so the coordinate vector of A relative to S is K1, is KA1, let's say KA1, which is, let's say K1, 1, 1, 1, 1, plus K2, 0, 1, 1, 1, plus K3, 0, 0, 1, 1, okay, and K4, 0, 0, 0, 1. Okay, so now we're going to do it with the same procedure as previous. And so K1 is equivalent from this part. K1 is equivalent to 1. Okay, okay, let me just make this easier for you. I'll just do it in matrix form. So this is 1, 1, 0, 0. Therefore, this is K1 based on this one, this cell is K1 plus K2. Based on this cell is K1 plus K2 plus K3. For this fourth cell is K1 plus K2 plus K3 plus K4. Okay? Therefore, based on this, we can conclude that K1 is equivalent to 1, K2 plus K1 equals to 0. Therefore, K2 is equivalent to 0. K1 plus K2 plus K3 is equivalent to 1. So this is 1 plus K3 equals to 1. Therefore, K3 is equivalent to 0. And K1 plus K2 plus K3 plus K4 from this cell is equivalent to 0. Therefore, this is 1 plus 0 plus 0 plus K4 is equivalent to 0. Therefore, K4 is equivalent to -1. And so the coordinate vector of A relative to S is 1, comma 0, comma 0, comma -1. So this is the coordinate vector relative to S. So next, this is the change of bases. And so let's say we have these two bases. We need to find this matrix, which is the transformation from basis from the old basis to the new basis. Okay. And in order to find that, we can use I forgot. Let me just we can just if you look at your book, there's a quick way to solve this, which is by, let's say this is the new basis and this is the old basis. And if we were to do row operations, we will get I to form I, which is the identity matrix. It will lead to the formation sorry, it will lead to the formation of wait, it will lead to the formation of P B alternate B to B accent, which is exactly what we're going to do today. And so the new basis is 2, 2. The new basis is this one, sorry. So this is 1, 3, and -1, -1, 2, 2, and 4, -1, equals, sorry, not equals. So now we're going to convert this into the identity matrix, which is 1, 0, 0, 1 in this case. Okay, so let's say R2 minus 3R1. So what we're going to get is 1 and 0. Okay, -1 plus 3, that's 2, and -1. And so 2, 2, 4 minus 1. And so this is 2 minus 6. Yeah, 2 minus 6, that's -4. And -1 plus -12, that's -13. -1, -12, that's -13. Okay. Now we're going to divide the second row by half. This is 1, 0, 1, -1, 2, 4, -2, -13 over 2. So what we're going to do next is add the first row by R2. So this is 0, -2. This is 4, sorry, 4. Yep, this is 4. Minus 13 over 2. That would be 8 minus 13 over 2. that would be negative 5 over 2. So this is negative 5 over 2. This is 4. And so your PB accent to PB is auto new. So sorry, your PB accent, sorry, B to B accent is equivalent to 0, negative 2, 4, negative 5 over 2. And in order to find this one, it is simply the inverse of this one. So because those two matrices have this relation. Equivalent to I. Sorry. Equivalent to I. And so the inverse of this is 8. Inverse. This is over the determinant. This is the adjoint matrix. For 2 times 2, it's easy. We just switch the 2 times 2 cell with the 1 times 1 cell, and then minus the 1 times 2 and the 2 times 1 cell by negative 1. So this is our inverse. Okay, moving on. This is our last question. We're asked to find the row, column, and null space basis, as well as the rank and the nullity. So first we'll deal with this 3 first. And for this, the first thing that we should do is convert this into the reduced row echelon form. So this is what we're going to get. That's right. One. So first we're going to knock out these 3 by R2 minus 3 R1, R3 plus R1, and R4 minus 2 R1. So what we're going to get is 1, 0, 0, 0. This is 4, 5, 6, 9. So minus 2 minus 12. Minus 12, that's minus 14. 1 minus 15, that's minus 14. 4 minus 18, that's minus 14. Negative 1 minus 27, that's negative 28. Now for the third row, this is 4, 4, 4, 8. And so the last one is, I think by now you should start seeing a pattern. 3 minus 8, that's 5. 5 minus 15. Sorry, 5 minus 10 is negative 5. 7 minus, sorry, 7 minus 12, that's negative 5. 8 minus 18, that's negative 10. So what we should do now is to solve this problem. So what we do is times R2 by negative 1 over 14 times R3 by 1 over 4 times R4 times negative 1 over 5. So get 1, 4, 5, 6, 9. This is 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, and 0, 1, 1, 1. Sorry, this is 2, 2, 2. Okay, so from this point, it will be very, very simple. We can just knock out the the third and the fourth row by using the second row as the pivot. So this is R3 minus R2 and R4 minus R2. So what we're going to get is 1, 4, 5, 6, 9, 0, 1, 1, 1, 2, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And the final step will be to knock out this 4 in order to make the evaluation complete. So it's going to be R1 minus 4 R2. And what we're going to get is 1, 0, 0, 0, 0, 1, 0, 0. R1 minus 4 R2. That's 5 minus 4. This is 1. 6 minus 4. That's 2. 9 minus 8. That's 1. So this is 0, 0, 0, 0, 0, 0. And so this is our row echelon, reduced row echelon form. So let me just move it to the next slide to make it clearer. This is 1, 0, 0, 0. It's 0, 1, 2, 1, 0. Zero. Okay. So this is 1. And all we have to do is find which part has leading ones. So this one, x1, and x2 has what we call leading ones. Okay, which is this one and this one. And the ones with leading, and the row and the column that has the leading one will be considered as the row and column spaces. So the row space would be 1, 0, 1, 2, 1, and 0, 1, sorry, 0, 0, 1, 2, 1, 2. No, no comma, guys. I don't know why I put the comma there. Okay, so this is your row space. So this is the column space. Would be, write it as a column, be 1, 0, 0, 0, and 0, 1, 0, 0. So that's your row space and your column space. And finally, we'll deal with the null space. And the null space is actually the solution space of, let's say, A equals XB. And this is your solution space. Okay. And your null space is your solution space of AXB. AX equals B. Okay, so now we're going to look at this, the final matrix that we got. This is a 4 times 5 matrix. Therefore, we have x1, x2, x3, x4, and x5. As you can see, x3, x4, and x5 does not have leading ones. Therefore, we need to assign them parameters. So let's say x5 equals t, x4 equals r, x3 equals s, and x2 has leading ones. And now we're going to write the equation. Sorry, solution space of AX equals to 0, not B. Sorry, my mistake. Okay. X2 plus 2x3 plus x4 plus 2x5 is equivalent to 0. Therefore, x2 is equivalent to negative 2, x3 is 2s plus r, x4 is r, plus 2t, because x5 is t. Okay? And so x1 is equivalent, so I'll just write here, x1 is equivalent to, I'll just make this quick, negative s minus negative s plus 2r plus t. Okay. So this is our solution. And what we call by the solution space is that we have to express this in terms of column matrices. So, and then also by factorizing it. So this is how we express it. x1, x2, x3, x4, and x5. And since we have three different parameters, which are t, r, s, so we have three different columns. This is r, t, s. Now we look at x1. The coefficient of x1 in r is -1, in t is -2, and in s is sorry, yeah, in s is wait, sorry, I think, okay, I made a mistake, sorry. So in r, negative x1 is -2, t is negative s1, and s is -1. But in x2, r is -1 here. S and t are -2 and -2. And if we were to look at x3, x3 only has s, so this is 1, this is 0, this is 0. R only has, x4 only has r, so this is 1, this is 0, this is 0. Same with x5. x5 only has t, so this is 1, this is 0, and this is 0. And these three are your solution space. And so because of that, these three are what we call your null space basis. This is column space basis, row space, column space basis, and row space basis. Okay. And the next part would be to find the nullity and the rank. And how do we do that? First of all, we need to, I'll introduce to you a new relationship, which is nullity A plus rank A equals to n, where n is the number of columns in the matrix. Wait. And so the nullity of A is the number, or rather the dimension of the null space. What I mean by dimension is how many matrices, column vectors that are formed in the solution space. And here we can see there are 3, so the nullity equals 3. In order to find the rank, it will be 3, n minus 3. And here we can see that there are four columns. How many columns are there? We have 5 columns. Therefore, the n is 5. So this is 5 minus 3, so we have 2. So the rank of this matrix, this previous matrix, is 2, and the nullity is 3. And the formal definition of rank, I think I'll just write it here. Rank is the number of leading variables in solution of AX equals to 0, while nullity is the number of parameters in solution of AX equals to 0. Okay, by number of parameters, it means this. We've expressed 3 parameters, which is why we've proven the nullity is 3. And since the rank is the number of leading variables in the row echelon form, and because of that, the nullity is equivalent, and we've proven that we have 2 leading ones. Therefore, the rank or the number of leading variables is 2. And so we're done with this tonight's assistance. So thank you for coming. And if it took a long time, I'm very, very sorry. And I hope that whatever I've given here, it'll be of use to you later in the exam. So just don't forget to study hard, and also don't forget to pray and rest. Okay, so that's all for me. Thank you, and you may leave the meet. But don't forget to fill in the forms, yeah. Help our friends in ACPRO. Okay, so thank you. I'll stop share, and you can leave.